Hello, this is Mrs. Ward, and this is take 2 of the 10.4 hyperbola video. Hopefully the sound will carry this time out. What we're going to do today, we're only doing the first 2 examples. We're going to write the equations of hyperbolas in standard form, and then we're going to talk about the asymptotes and sketch a hyperbola. Just to review, when we first started talking about conics, we talked about our double mat cone. And what a hyperbola is it's taking that plane and intersecting it so that I have an intersection here, intersection here. So they look like 2 parabolas that open in opposite directions. These parts are called branches, and the branches are symmetrical. They're the same shape, just on opposite sides. So we're going to talk a little bit about how to find all that. So first of all, the definition of a hyperbola is a set of all points in a plane, and the difference of whose distance from 2 distinct fixed points, the foci, is a positive constant. So if you remember from the ellipse, we talked about having those 2 foci, and we said any point on the ellipse, if I take this distance and I take this distance, and we added those 2 together, that was going to equal some constant. Well, with a hyperbola, it's basically the same idea, but if I take this distance, whichever one's larger, and subtract this distance, so if I take d2 minus d1, that is a positive constant. Again, we always have to make sure we take a larger distance minus a smaller distance to make it positive. Just like we did before, we're going to have pieces and parts to this. First of all, these are called branches. So these are branches, and our branches will either open north, west, south, east, up and down, left or right. So when I look at this, I still have distance from the center to the foci is still going to be the letter C. The distance from my center to the, oh, I said that wrong. I am so sorry. I would love to record that I don't have time. The distance from the center to the foci, there we go, that's the letter C. The distance from the center to this point here, which is the vertex, that's still the letter A. Then we have another point B, which is still part of our equation, but B is not part of the branches or anything like that. So when we have our formula sheet, that we are going to have the same standard form of the equation of the hyperbola. Looks very similar to the ellipse, but here are some of the key differences, huge differences actually. I have a minus sign here instead of a plus sign. That minus sign takes it from being a connected shape to 2 shapes that go in opposite directions. You will notice here that also the a squared is no longer the largest number. The a squared is a number that is with a positive variable. So, and then what's going to change is the order of the x or the y. So here the x is positive, the a goes with the x. That means it's going to have a transversal axis horizontal, which means that my branches are going to go east and west, or left and right, however you want to think about here. My y is a positive variable, the a goes with the y, which means my transversal axis is vertical, so what it hits in the half is vertical, so it's up and down. So if you're not sure, that's what these pictures are down here. Transversal axis is horizontal. You'll see that the x squared comes first. That means the x squared is positive. Transversal axis is vertical, so again, they open up, down, north, south, however you want to think about it. The y is positive. The other major change on this formula sheet is that the a squared, how I get a and b and c, how they're related. Now it's oopsie, I didn't block that out. I want to say it's highlighted. C squared is equal to a squared plus b squared. So for a ellipse, it was c squared was equal to a squared minus b squared. A was always the largest number for an ellipse. Now for a hyperbola, a squared may be the smaller number, but it doesn't matter because it's a squared plus b squared divided c squared. Okay, so let's do the first example. So the first thing I'm going to do is I'm going to sketch this so that it has foci at 0, 0, and 8, 0. So foci at 0, 0, 8, 0, which means the center has to be halfway between those 2, because back in the formula, I don't know if I told you, but the h and the k are still my center. So my center is going to be halfway between those 2, which is going to be the point 4, 0. So there's my center, and then since these are where my foci are, I know my branches have to come out right, which means the x is going to come first. So I'm going to have x minus 4 squared over some number minus y squared over some number is equal to 1. Oh, all right, so then I am going to, then it tells me the vertices are 3, 0, 1, 2, 3, 0, and 5, 0. So here are my vertices. The distance from my center to my vertices is 1. That's going to be my A. So A squared will be 1, so I'm going to put 1 here. Then the distance from my center to my foci, the distance from my center to my foci is going to be my C. So my C is going to equal 4. So I'm going to use the formula C squared is equal to A squared plus B squared. So 16 is equal to 1 plus B squared. B squared is equal to 15. So I don't have to take the square root. I just can put 15 here because that's B squared. And that is my formula. And I'm going to see if they want anything else. Find the standard form of the equation of the hyperbola. Nope, that's it. So let's move on to the next one. So the next one talks about the asymptotes of a hyperbola. So if you remember, when we talked about asymptotes before, you used to talk about the vertical asymptote. And what a vertical asymptote does is it's a line that your graph approaches but never really touches. So that's what an asymptote is. These asymptotes are usually going to be slanted, so they're going to make like a crisscross. So the equations are going to be h and k. So this is like point slope. In point slope, you just do like y minus y sub 1 is equal to my slope times x minus x sub 1. So this is where the formulas come from. The x sub 1, y sub 1 is going to be your center. So that is going to be your h and your k. So that's why I have, and then they took this and they put it over the other side. So that's where the k comes from. This is the x minus h, which is that there. Then the b over a or a over b is going to be the slope. It depends on how the hyperbola is looking. So if I have the branches going left and right, the distance from here to here is my a. The distance from here to here is my b. And the only time we use b is to form this box to make our asymptote. So in this case, my slope is b over a, rise over 1. And that's why it's written here b over a. Now if my branches went the other way, so in other words, I went like this to this, my distance from my center to my vertices will be my a. When I make my box, the distance from my center here would be b. That's why my slope is rise, which is a over b. And that's why it's the exact same formula except for your slope just changes. And we're going to be able to use these asymptotes for the equation of our hyperbola. So this one is asking me to sketch the hyperbola with the given information. So it gives me the equation, which is 9y squared minus 4x squared is equal to 36. Again, all these have to be set equal to 0. So the first thing I'm going to do is divide by whatever number this is. So I'm going to divide everything by 36. When I do that, I get y squared over 4 minus x squared over 9 is equal to 1. Now the y comes first, which tells me your branches are going to go up and down. That's what the y squared tells me. Since the 4 goes with the positive variable, or the y, the a squared is going to equal 4, which means a is equal to 2. The b squared is the one that's with the other variable, which is 9, so my b is equal to 3. And I'm okay that my a is smaller than my b, because that will happen a lot with hyperbolas. Since I'm not subtracting anything from my x or my y, my center is going to be 0, 0. So I'm going to sketch that first, 0, 0. The a is the distance from my center to my vertices. So I'm only going to have one set of vertices. I spelled that wrong. So my vertices are going to be 2 up and 2 down, because again, they're vertical. So 1, 2, 1, 2. So there are my vertices. And then I want to sketch this, so I really need to know how wide or thin my branches are. So that's what the box is going to help determine, is how wide or thin the branches. So I have my vertices, and then the B will help me round out my box. So the B is 3, so I'm going to go to the center, and I'm going to go 3 to the left, 1, 2, 3, 3 to the right, 1, 2, 3. And then I'm going to use these dots that I have, and I'm going to make a rectangle box. And I'm going to highlight that. So my box is going to look something like this. So 2 up and down from the center, 3 left and right of my center. Then to sketch my asymptote, so I'm going to go from the corner of the box to the corner of the box through that center point. And that's going to give me my asymptote, which kind of and so let's be a little bit better about that. Continue this line, and then I'm going to do the other one from corner to box, through the center, as far as I can go. You can use your calculator when it has a straight edge, to get these lines nice and straight. And those are my asymptotes. So when I go to sketch my hyperbola, I'm going to use the vertices and I'm going to approach those asymptotes. And that's what my browser will do. All right, I hope this helps, and I'll see you next time.